In this video, we're going to be looking at curves intersecting other curves. Okay, so we're going to be using a similar process to what we've used before, but the algebra gets a little bit more complicated usually. So if we have a look at number 1, we've got y is equal to x minus 1 squared and y equals 2x minus 3 squared. So we actually have two parabolas intersecting one another. So we're going to put one equal to the other. So x minus 1 squared is equal to 2x minus 3 squared. So the first job is to expand those brackets out. So we'd have x squared minus 2x plus 1. And 4x squared, we've got minus 6x twice, so minus 12x plus 9. We then want to move everything onto one side of the equation. So if I move everything onto the right, we can subtract an x squared from both sides. We can add 2x to both sides. And then we can subtract 1 from both sides. Okay, so we now have this quadratic to solve. So at this stage, we might want to go straight into using the quadratic formula, or we can attempt to factorise. I'm going to use the formula. So x is equal to minus b, so 10, plus or minus b squared, 100. Take away 4 times 3 times 8, 4 times a times c, square rooted, all over 2a, so 6. So we get 10 plus or minus. Now 100, take away, well, 4 times 3, or rather let's do 3 times 8 is 24. 4 lots of 24 is 96. So that's 100 take away 96, and so it's just 4. So 4 square rooted would be 2. All over 6. So we get 10 plus 2 over 6. So 12 over 6, which is 2. Or 10 take away 2 over 6, so 8 over 6, which is 4/3. So the x-coordinates of intersection are 2 and 4/3. Okay, so if x is 2/3, if x is 2 rather, then I can substitute 2 into either of those two equations to work out the y-coordinate. 2 take away 1 squared, so 1 squared is just 1. And when x is 4/3, I get 4/3 take away 1, which is 1/3. 1/3 squared is 1/9. Okay, so those are the coordinates of these two parabolas, of where they intersect. So visually, what does that look like? Well, what you have is one parabola at x minus 1 squared. So that would be a parabola with vertex at 1. Just sits on the x-axis like that. And then you've got one at 3/2. So it would sit there. Okay. But because it's it'd be a 4x squared when expanded, that means it's going to be steeper. So you've actually got these two intersection points. Okay? So that's something to consider here, that we would have 2. And as we say, the first, we've got 2, 1, which would be that one, and 4/3, 1/9, which would be that one. Okay? So there's the first example. Okay, so next up we've got y is equal to x squared and y equals x cubed. So we're going to put one equal to the other, so x squared equals x cubed. Now it would be very tempting to divide both sides by x squared at this point, but we can't because that will lose us solutions. So I'm going to subtract the x squared from both sides. Then I would need to factorise that. And so I would get x squared times x minus 1. So either x is 0 or x is 1. Now if x is 0, I can just substitute that into either of the two original equations to get 0. and when x is 1, I can substitute that in and I would get 1. So we have two intersection points. So visually, we have the parabola at y is equal to x squared, and then we've got the cubic, y equals x cubed, which has its turning point at the origin, so that's where they intersect. And then what happens is that the curve will start off slower in increase, because between 0 and 1, x cubed increases slower than x squared. But when you hit 1, 1, that's where they are the same, and then x cubed takes over and increases more rapidly than x squared. So you've got the two intersection points. Okay, so number 3. Y is equal to x squared minus 5, and y is equal to 2 over x. So we're going to put one equal to the other. Okay, so now I'm going to have to multiply both sides by the x. So x cubed minus 5x equals 2. And then subtract the 2 from both sides. Okay. Now at this stage, in order to solve the cubic, I'm going to have to find a factor. So I'm going to use the factor theorem. So if I let f of x be x cubed minus 5x minus 2, let's try some factors of 2, or factors of the minus 2 rather. So f of 1 is 1 take away 5 take away 2, which is minus 6. So that didn't work. I need to find 0. Let's try f of minus 1. So minus 1 cubed is minus 1. Minus 5 times minus 1 is plus 5. And then take away 2. So we get 2. So x plus 1 is not a factor. X minus 1 is not a factor. So let's try f of 2. 2 cubed is 8. Take away 5 lots of 2. So 10. Take away 2. So that would get me 8 take away 10 is minus 2. Take away 2 is minus 4. So that's no good either. Let's try f of minus 2. Minus 2 cubed is minus 8. 5 times minus 2 is minus 10, but minus that, so plus 10. And then take away 2. So that would actually get me 0. So therefore, x plus 2 is a factor. Right. So because x plus 2 is a factor, I can use polynomial division now. So x plus 2. And we've got the x cubed. That would have to be x squared, 2x squared. We need 0x squared, so take away 2x squared there, so that'd be minus 2x, and minus 4x there. We need minus 5x, so that'd be minus x. X is into that, go minus 1, and then we'd have minus 2. So that would mean that this is the same as saying x plus 2 times x squared minus 2x minus 1 equals 0. So either x equals minus 2 or x squared minus 2x minus 1 is 0. Now we need to solve that quadratic equation. Now this quadratic doesn't factorise, so I'm going to have to use either the quadratic formula or completing the square. So I'm going to go with completing the square. I haven't done that for a little while. So x minus 1 squared, take away 1. We've got the minus 1 there as well. Okay. So we're going to have x minus 1 squared is equal to 2. So x minus 1 is plus or minus the square root of 2. And then add 1 to both sides. So we actually have 3 intersection points. We've got minus 2, 1 plus root 2, and 1 minus root 2. So, in order to find the y coordinates for this, we would have minus 2 2 over minus 2 is minus 1. And we've also got 1 plus root 2. And the y-coordinate would be 2 over 1 plus root 2. Now you could rationalise the denominator for that if you wanted to. And 1 minus root 2 over 2 over 1 minus root 2. Okay, so they are my intersection points. So visually, what's going on? Okay, this is a little bit more fiddly to draw, but I'll have a go. So, what have we got? We've got this y is equal to x squared minus 5. So there's y equals x squared minus 5. Okay, so that's down at minus 5. And then you've got this 2 over x. Okay, so the 2 over x must come through and make that intersection point there. And it must come up and through like that, making 2 intersection points there. Okay, so this one there, that must be this one. Okay, the 1 plus root 2, that must be that one, because they're both positive. Now, that one, they're both negative, and that one, they must both be negative as well. So, which is it? Which one is which? Well, minus 2, you've got minus 2 and 1 minus root 2. Now, root 2 is about 1.4 something. So 1 take away root 2 must be minus 0.4 something, which is less than the minus 2. So the minus 2 must be that one, and this one must be that one. Okay? But obviously you could check on a calculator as well. Right. Okay, so that one was a little bit more involved. So number 4, y is equal to x minus 2 squared. So x minus 2 squared is equal to 4 over x minus 1 squared. Okay, so I'm going to multiply up first, like so. Now I'm going to need to expand those brackets. So, what are we going to get? So, we're going to have x squared minus 4x plus 4 in the first bracket, and x squared minus 2x plus 1 in the second bracket. I'm going to have to multiply that out as well. So, we're going to get x squared times x squared is x to the 4. X squared times minus 2x is minus 2x cubed. Then we're going to get an x squared from x squared times 1. Minus 4x times x squared is minus 4x cubed. Minus 4x times minus 2x is plus 8x squared. And minus 4x times 1 is minus 4x. 4 times x squared. 4 times minus 2x. 4 times 1. And remember we've got the equals 4 on the outside as well. So we're going to have x to the 4. Minus 2x cubed, take away 4x cubed is minus 6x cubed. X squared, 9x squared, 13x squared, like that. Minus 4x minus 8x is minus 12x. And then the 4's can cancel from both sides. So we now have this quartic to solve. Now, from that, we can pull an x out. Like that. Okay. Now at this stage, I would have to use the factor theorem to find my factor well, a common factor for that cubic. So I know from setting this problem up that if I substitute 3 into this, I get a root, okay? So I'm going to kind of like fast forward. I mean, if you didn't know what the root was, then you would have to substitute in 1, then -1, then 2, then -2, then 3, and then you'd get there, because you have to use factors of -12. Okay, so we've gone through an example of that. You can try it out, but x equals 3 is the root. So that means that x minus 3 is a factor. So we can use polynomial division. So we're going to have x and minus 3, and we want the x cubed. So we're going to have x squared there, minus 3x squared there. We want minus 6x squared, so minus 3x squared again. So minus 3x, 9x. We want 13x, that's got to be 4x. That's got to be 4, that would have to be minus 12. So that means that we now have x times x minus 3 times x squared minus 3x plus 4 equals 0. So we definitely have two real roots, x is 0 and x is 3. But we've also got this quadratic here. Now, in order to solve that quadratic, we could use quadratic formula or complete the square. So if we tried the quadratic formula, we'd have x is equal to b minus b plus or minus b squared, take away 4ac, so 4 times 1 times 4, so 16. So you can clearly see that we're going to get a negative inside the square root, okay, and so there are no real solutions to x squared minus 3x plus 4 is 0. So the only two roots are x is 0 and x is 3. So when x is 0, I can substitute that into one of the two original equations, so either of those. So if I tried that one, 0 minus 2 all squared is 4. And when x is 3, I'm going to get 3 take away 2 all squared, which is 1. So there are two intersection points. Now, visually, what's going on? Well, let's try and draw a picture of this. Okay. So what do we have? We've got x minus 2 squared. So that would be a parabola that looks something like this, sitting on the x-axis at 2, going through the y-axis at 4. You've got y is equal to 4 over x minus 1 squared. So this would have an asymptote at x is equal to 1. Okay. Now it should then look something like this. Okay, so something like that going through. And because we know it's going through 0, 4, it must look like that. So 0, 4, and this point must be 3, 1. Okay, and that is a picture of what's going on for number 4. So finally we have number 5. And for number 5, we've got y is equal to 6 over x minus 1, and x squared plus y squared equals 8. So here I've introduced a circle. Okay, so that's the equation of a circle centered at the origin with radius root 8. Okay, so what I can do is I can substitute that into that one. Rather than putting them both equal to one another, I can substitute that one in directly. So we'd have x squared plus y squared. Now y is given by 6 over x minus 1, and I'm going to square it, and equals 8. So let's tidy this up. We've got x squared plus 36 over x minus 1 squared is equal to 8. So if I multiply everything by x minus 1 squared, get x squared, x minus 1 squared plus 36 is equal to 8 lots of x minus 1 squared. So x squared times x squared minus 2x plus 1, so that's that bracket there, plus the 36, plus, equals, rather, 8 lots of x squared minus 2x plus 1. So multiplying through, we've got x to the 4 minus 2x cubed plus x squared plus 36 is equal to 8x squared minus 16x plus 8. Okay. So now I'm going to subtract 8x squared from both sides, like so. I'm going to add 16x to both sides and take 8 from both sides. So I would get 28. Right, so now we're going to use the factor theorem again, okay? I've got a quartic, so I would have to use the factor theorem. So from that, I would try 1, I would try minus 1, I would try 2, I would try minus 2, okay? Until I started to hit value. So I try factors of positive 28. Now I know from setting this question up, like before, that minus 2 is a root of this quartic. So that means that x plus 2 should be a factor. So x to the 4, so we're going to have x cubed, 2x cubed. We need minus 2x cubed, so minus 4x cubed. Then minus 4x squared. Then we're going to have minus 8x squared. Then we need minus 7x squared, so we want to add an x squared on. We're going to have x, 2x. We need 16x, so that's going to be 14x. So that would be 14, and that would be 28. So x plus 2 times x cubed minus 4x squared plus x plus 14 equals 0. So that means that either x is equal to minus 2 from that bracket, or we're going to have some roots from this bracket. Now, if you're going to use the factor theorem again, remember if you were going to substitute values in, if it didn't work for that quartic, then you're not going to find them in that cubic either. Okay, so they're not going to work. If it doesn't work for that one, it won't work for that one either. Okay, and what happens is that we quickly run out of options with this, and there are actually no nice roots to find for this cubic. So using a calculator or something similar, we've got 1x cubed minus 4x squared plus 1x plus 14, and we get that the only other real root coming from that is x is equal to minus 1.51 to 3 significant figures. Okay, it's actually minus 1.506311955. Okay, and it continues. But they're the only two real roots that we're talking about here. So, if I write down the more exact version, so I can substitute it in. So if that is the x value to 3 significant figures, then if I substitute it into this, we get minus 1.506311955. Take away 1, we get minus 2.39 to 3 sig fig. And when x is minus 2, we get 6 over minus 2 take away 1, so 6 over minus 3, which is minus 2. So we actually have these two coordinates of intersection. So visually, what's going on? Now, visually, we have a circle okay, not very good. That'll do. Let's tidy it up. So something like that. Okay. So there is my circle. It's got a radius of √8. Okay. And then you've got this 6 over x minus 1. So a curve that has this asymptote at x equals 1, this vertical asymptote, and it is intersecting the curve, the circle rather, at 2 points, both of which are in the negative quarter. So it must do something like that in order for the two intersection points to be within that area of the graph. We can determine that it intersects the y-axis when x is 0, so 6 over minus 1, so that must be minus 6, that point there, which is definitely larger than minus √8, so like further down than minus √8. And then the other part of the curve, well, it must miss the circle completely. Okay, and so this must be a picture of these two curves.